We have a great session lined up this morning and some really exciting recent news, which will just be one part of the story that I'm sure we're going to talk about this morning. So I wanted to get this teed up for us. I'd like to welcome the team from CMR Surgical here. For those that don't know, I'm sure many of you do, CMR Surgical is a surgical robotics company, and they're behind the next generation surgical robotic Versius. And the company is on a mission to help get keyhole surgery to all patients who need it around the world. With Versius being used in over 20 markets, today's session will spotlight the company's founding story and a deep discussion about what the future of this market looks like. We're thrilled to have the entire team here today. We have Luke Hares, who is a co-founder, CTO, and original inventor of the Versius. We have Mark Slack, also a co-founder and their chief medical officer, and their CEO, Supratim Bose. So welcome to the stage. If you didn't see the press release yet, take a look at it. We want to congratulate the team. They had a very timely announcement that went out today announcing that their system has now been used in over 15,000 surgical cases in more than 20 countries around the world across various specialties, including general, urological, gynecological, and thoracic. And they also announced today that they closed an additional round of $165 million with some very impressive investors joining their journey. And so very much looking forward to not only hearing about how they got here, but where they see things going. And again, the point of this whole meeting is to shine a light on the innovators that are changing the world. And no doubt they have a big mission here, and we're encouraged to see them here on stage with us today. So with that, I'm going to turn it over to Henry, and over to you. Thank you.
Thank you, Scott, and thank you, everyone, for joining us. First, please just join me in giving a short round of applause to celebrate that recent news. And as Scott mentioned, we're thrilled to have you here on such a timely fashion to talk about not just that news, but where Versius started, how CMR Surgical has grown, and how this is going to fuel the next generation of that expansion. So let's jump right into it, starting with Dr. Slack and with Luke. Tell us how CMR Surgical got started, the origin story of what is now 15,000 surgeries strong.
Yes, certainly. So prior to CMR, I worked in the contract research and development businesses around Cambridge, well known, there's many of them. And the joy of those businesses as an engineer is you get exposed to a huge number of industries and opportunities. And some of my work was in the field of surgical robotics. That project ended, as of course all projects do, and I then went on to work on handheld steam cleaners. But the thing that remained with me was that there was this massive unmet need that really no one was, to my mind, effectively working on. Laparoscopic surgery, minimal access surgery, had been out for, and this was 10 years ago, so 30, 35 years, and the penetration of it had only really got to 50%, even though it was obviously a better way for the vast majority of people to have the vast majority of procedures. Robotic surgery, been around for 15, 20 years, had really only got to 5 or 6%, depends how you count, and wasn't moving the dial on that 50%. It wasn't providing the majority of surgeons a better way to give minimal access surgery to the vast majority of people. There was clearly a need for a better tool to enable everyone to have that. I'm lazy, so I like to find the easiest way to do things. I like to invent tools. And CMR really was founded on the assertion that actually you could invent a surgical robot that would help the vast majority of people to have the right kind of surgery. And if you look at Versius, all the features of it, and Versius is, I think it's fair to say, still radically different to the surgical robots, other surgical robots on the market. All those features come from the questions we asked ourselves 10 years ago. How do you build a system that is physically capable of doing all sorts of surgery in the way that surgeons want to do it? So you're not physically constrained by the design of the system. How do you make it easy for surgeons to learn how to use, for bedside staff to learn how to use, because you've got to get the turnaround times down, to fit into existing hospital ORs, existing hospital workflows? If you can do that, you've got a system that can be used for everything, and you've got lots of people who can drive it, both surgeons and staff. If you can achieve that, you can keep it busy. You can get the utilization up. 4 or 5 procedures every day, day in, day out. Achieve that, and you completely transform the economics of providing it, and everyone can have one. Now, that was the basic premise that was the foundation for CMR, the belief that actually, if we put the system together like this, it will achieve that. The thing that's been tremendously exciting over the last couple of years is, as the numbers show, and actually as you dig into the numbers even further, you'll see that we've got systems out there that prove that Versius does meet those requirements. And that's what's tremendously exciting. We've got the systems that are being kept busy, and we've got the systems that are doing just about everything you can imagine, and a few things that, frankly, back then we didn't imagine. So right at the beginning of that expansion, right at the beginning of starting to move the dial and helping millions of people get the right kind of surgery.
Good. Well, I think we have everyone's attention now with that founding story. So rather than start by doing something like intros, I want to make sure everybody's engaged and understands where we're coming from. I think now's a good time, now that we have their attention, to introduce everybody, starting on my left with Supratim. We'd love to do a quick intro, and then we'll go back into a little bit of that clinical space that you were talking about and some of the under-penetration of the market.
Hi, I'm Supratim Bose. I'm CEO of CMR. I was appointed CEO about 5 months ago, but I've spent more than 4 decades in the Medtech industry, having worked for Johnson & Johnson Medtech for 30 years, for Boston Scientific for over 7 years, and then Convatec for around 3 years.
Hi, I'm Mark Slack. I'm one of the co-founders. I'm a lapsed surgical academic. I was head of a department at Cambridge University. I've also interspersed my career with other inventions, some of which I've taken to global launch with Johnson & Johnson. And, people make an assumption. I ran a laparoscopic training course in Cambridge for about 25 years and became aware that I couldn't teach everybody how to do straight stick laparoscopy. They would spend 2 years with me, and at the end of it, still were struggling to get to grips with it. And as Luke highlighted, less than 50% of people getting surgery get minimal access surgery, despite the myriad of advantages which we can come back to. So people make an assumption that Luke and I, both living in the Cambridge ecosystem, met through science and innovation, but in truth, we met through antenatal classes where both our wives were attending. Yeah. Luke did attend, I didn't, and my wife was asked if she had a partner, and she said, yes, I'm married. And they said, well, you must ask him to come along. And she said, believe me, you don't want him at these classes. So that's where we actually met, but it was great because she's also a surgeon, and Luke spoke to her and said, I'm concerned about, I want to get into robotics. She said, the lunatic at home is talking about it as well. And, I had tried out the other systems, and it was interesting to me that something different was needed to try and meet the need of getting more people getting minimal access.
Luke Hares, CTO, co-founder of CMR Surgical, and the inventor of the idea of Versius, though I always like to point out that it's the work of hundreds of other engineers as well. My background is that I'm a physicist. Studied physics at Cambridge and then went to go and work in the various technology development companies around Cambridge. That was good. Worked on many, many different things until eventually discovering that there was this need and being very excited because I thought I had a way to do something about it.
Great. And now we have the backgrounds, we have the founding story, and I think we need one more piece of information, the market and the clinical need, to help really set the stage for where CMR is now. So Dr. Slack, can you talk to us a little bit about what you had seen in the market around surgical robotics and why the market penetration, as we had talked about, had been so low? What's kind of going on in the clinical community at that time, and what was that unmet need?
Yeah, I think there's a narrative, part of which Luke has already covered very fluently, but the point is, you have to go back and say, is minimal access surgery better than open surgery? And in every single domain it is. Just in general complications, reduces complications by 50%. But if you take something like surgical site infections, wound infections, if you have a big wound and gets infected, half of those people go back to hospital and 10 to 20% go back into theater. Whereas in keyhole surgery, nobody goes back into hospital. And the European economy spends about 27 billion euros a year on wound infections. So, we're talking about economies of scale that will have an impact on the health system. They're so massive. Yet, despite all of those, we only get United States of America, inverted commas, the most sophisticated health system in the world, only has a penetrance of about 40% of minimal access in most specialties. And so that's one of the things that intrigued me. And what I mentioned earlier is, from my own experience in training people, I realized not everybody is capable of operating in 2 dimensions with instruments that go in the opposite direction to where you move your arms, et cetera, et cetera. And so, therefore, would robotics overcome that? What struck me, and I did look into the other robotic systems, was that they've been around 22 years and yet got a penetration of about 4%. So clearly, we spoke to surgeons. We asked about 150 surgeons in a Delphi poll to say, why are they not adopted robotic surgery? And they spoke about cost, size, different ports, different port placement, different methodological approach to those operations, etc. And then said to us what they wanted was a small modular robot that could be used in all specialties, portable, etc., etc. And that's what the company has set out to take Luke's vision of this much smaller portable robot and put it into use. And one of the things we already see, it is way easier to train a surgeon on a robotic system than it is on a straight stick traditional laparoscopic system. Just having the 3D and the fixed focal length from your screen and the articulated instruments, I can probably teach most of you in this room to tie a knot in about 30 minutes. Whereas with traditional laparoscopy, to do it fluently, it would take you about 70 to 80 hours of practice. So these are these economies of scale that, and you know, I do believe that, and we already are showing people who've never done laparoscopy now using our system. And so I believe that robotics will drive the minimal access market up to the 70, 80% of surgeries where it needs to be, with all the benefits for the people who receive the surgery.
I think it's, sorry, I think it's fair to say you did teach Matt Hancock, the then British Health Secretary, to tie a knot in about 15 minutes.
Yeah, and if you see the pictures of him in the newspaper, you realize he's pretty good with his hands at the time. But anyway, that's an issue.
On that topic of training, kind of on another statistical area, if you had to take an estimate or maybe some internal research that you've done, what percentage of surgeons in training do you think in the future will be training on robotics? I think a lot of what we've seen today has been trying to convert surgeons that came up in laparoscopy over to robotic surgeons. But for that next generation of surgeons, where do you think on the 0 to 100 spectrum, how many of them, what percent will be training with robotics?
So I work very closely with the surgeons in training. In fact, we sponsored the Association of Surgeons in Training and did a survey of them, which is published now. And 98% of them have an expectation that they will practice surgery with robots. They do not anticipate and that's partly because of ease of acquisition, partly because potentially better results in some areas, and also because of their knowledge of ergonomic injuries. So with straight stick laparoscopy, where you're standing in odd positions for hours on end, people get a lot of cervical spine injuries, they get arm injuries, and the younger surgeons are very mindful that they don't want to get that. So there's a drive. I spoke a week ago with them at a meeting, and they are all, we now have virtual reality headsets for our training, which we can come back to, and they all want one because they want to practice it so they can go to their bosses and say, I can really do this.
Makes a lot of sense. The founding story you talk about relates a lot to the architecture of the system, the clinical need, and why it's designed the way it is to be smaller, modular. But Versius is more than hardware, it's software as well, and that software-driven ecosystem plays a big role in why this system is set up for both immediate and long-term impact. Luke, can you talk a little bit about that software-driven ecosystem and what that will enable in the future?
So Versius is, and I'm assuming a level of familiarity of Versius, it's very different from most surgical robots, because when you look at Versius, you can see immediately that it is based around small, flexible robot arms. The design breakthrough that allows it to be that way is the wrist. It gives us the range of motion with small, flexible robot arms. It was also designed from the ground up to be part of a digital ecosystem. If I expand on the robot side first, and then I'll talk about the digital ecosystem. On the robot side, because so many of the things that in other systems are mechanical constraints, like rails and how you move it during setup and things like that, are in Versius software constraints. They're programmed behavior. It means that over the years, Versius has undoubtedly got better. Movements have got smoother, setup times have got better. We've taken the learnings that we've had from the field and we've incorporated them into Versius, and everyone has benefited from them because the principal way to incorporate them is by improving the software and the system. So its behavior is very software defined. That gives us a level of flexibility not everyone anticipates. So that's tremendously exciting. But as I say, it was designed to be part of a digital ecosystem. And if you say that we're coming to like maybe the end of the first chapter in terms of the introduction of the robot, when it comes to the digital ecosystem, we are just starting the book. Versius streams back to base complete information about how a surgery is performed. You know, you've got the video, but again, the video is kind of old hat. You've also got the way the instrument tips are moving and the way the surgeon is moving the controls. You've got the way it was moved around during setup. You've got what buttons are pressed. We can play back procedures on virtual Versiuses, and we can do it for every single one of the 15,000 procedures that Versius has performed. It's a tremendous amount of detailed information. You know, people talk about doing image recognition to work out where the instruments are. Great, we know where the instruments are. They're held by robot arms that know exactly where they are to within fractions of a millimeter. The question then is, you know, what do you start to do with that? And we're already at the first stages of sort of taking that information and using it internally to inform development decisions and to inform servicing decisions. So I think that joint is looking a bit worn. We should go and fix that before the surgeon notices. And we're also starting to feed that information back to surgeons and back to surgical teams. This is the telemetry information. There's the clinical side of this, the registry that I'm sure Mark will talk about in a few minutes as well, and that's absolutely essential and part of this too. And really that feeds into a really important question that I get asked quite regularly, which is, does Versius make surgeons better surgeons? It's sometimes a trick question a reporter sends in. And the answer, annoyingly, of course, is both no and yes. It's no because the surgeon who stands up from Versius is exactly the same surgeon who sat down at Versius. But on some levels, it's also yes. It's yes, perhaps, because they've got a much better tool to work with, so they can operate for longer, more comfortably. They can perhaps operate more, do more complex procedures. Their patients may feel that they're a better surgeon, but the real reason it's yes is because every surgeon I've met cares deeply about their patients and cares deeply about serving them better. And the thing that lets surgeons serve their patients better is information they can learn from. And that really is what the first step of the digital ecosystem is, showing surgeons how their numbers are changing, how they're improving, as they're using Versius, showing them the areas where perhaps they could do a bit better. You know, here's a metric for tying knots, and actually you're over here. And that really is just the very, very beginning, because the other thing that you get when you've got a full telepresence laparoscopic robot system is, for the first time, you're putting something between a surgeon and their patient which can, if necessary, intervene. You know, currently, Versius is very simple. You move your hands up, down, left, right, you move your wrists, the robot moves the instruments inside the patient in exactly the same way. It makes no judgment as to, is that a sensible thing to do? Actually, in the not too distant future, based on these data sets, I can see Versius going, are you sure you want to do that? I mean, let me give you a trivial example. Currently, if you try to fire an electrosurgery instrument you can't see, Versius will let you. It makes no attempt to meet it. I can't think of a single good reason to fire an electrosurgery instrument you can't see. And actually, I would be much happier if Versius went, are you sure, before it let you do that. That's a simple example. But when you take that enormous clinical data set, the clinical outcomes stored in the registry, the exact information around how procedures are performed, I can imagine a future where Actually, down the line, the system says, hang on, in 5 minutes' time, 5% of surgeons in this situation had a problem. Now, that's in the far future. We're not there yet. It's going to be a journey. You know, it's got to be a journey. But I can see it starting to happen. And that's going to be tremendously exciting.
But using that same digital ecosystem at the moment, we already have it in place. So for training, our training is obviously on electronic, online and so on. And then we have virtual reality, both for the team and for the individual surgeons. So I could potentially train a team with one surgeon in Barcelona, one in Cambridge, and one in Oxford, working together over VR, setting up the system. So by the time they come to the laboratory to learn, they already are proficient, and it also means they don't have to spend all the money flying across to train and so on and so forth. In the training system, we have virtual reality for the simulator, and our female surgeons complained that they could only get on the simulator when the robot wasn't being used, which is usually in the evening or weekends in theaters which are quiet and dark and not exactly friendly places to be, whereas now they can sit at home and practice in the comfort and warmth of their homes on the VR. But of course, what we put into the VR is that it is proficiency-based. So I don't say that the surgeon is good enough yet. The system says the surgeon has passed certain proficiency tests and is now ready to go on to that next step. And already with the telemetry that Luke mentioned, our robot with about a 99% accuracy can tell the difference between a novice surgeon and an expert surgeon by their hand movements. So you get these glimpses of stuff that we're already using in our day-to-day practice in order to enhance it. Now, the digital aspect of training with proficiency means that if you have a particularly talented surgeon, they may train in an hour and then be ready to move on. A less talented one make 2 or 3 hours. But either, whatever you do, you're ensuring that they're reaching a benchmark which makes sure that they're safe for the patients that they're operating on. And then also, all of this is collected. So their data is all on an automatic logbook. When they train on the simulator, it all gets clicked automatically into logbooks. They know exactly what they've done, and that's there to show people if there are any questions about their training. So, and that's just the beginning. There are a million other ideas we have in and around the digital side here to determine better outcomes.
I think it's a perspective shift. A lot of the conversation around surgical robotics, even when I was in school studying surgical robotics and starting at Intuitive and J&J, the conversation is around hardware innovation, making better tools, better devices, better control paradigms, whereas the conversation now and what you're putting out is, hey, for the first time, we have laparoscopic surgery in zeros and ones. We have all this information that we didn't have before. What can we do with it? And that, I want to kind of parlay over to you. Supratim, you have an incredible career with global corporations, strategics up to this point. Why now to take on this role at a scale up like CMR Surgical? What drives you to come in at this point and help bring this company into its next phase of growth?
I think the first thing is that I have been involved in the Medtech and continuously looking and studying where Medtech is headed in terms of providing benefits to patients on a global basis. And when you look at it, robotic-assisted surgery would probably become one of the largest segments of the Medtech industry and if it is properly done, reach the maximum number of patients possible here. So when I was contacted for this, that's the reason I looked at it. And number two, the vision, and as you listen to both of them, somehow they came up with the right thinking and the vision that their goal is to make robotic-assisted surgery available to most patients available. Yeah. So partly repetitive, but the fact is to really think through and see why laparoscopic and robotic surgery penetration is still so low, like this, more than 20 years. And I think that's the interest that brought in. I think the first thing to look at is really understand how to access, which markets to access, and how you go about creating the access story. Number two is looking at and saying, creating the awareness in a manner that both of them express. If you listen to them, it's that message which must go across to the community, right? It is available, the training is not difficult, it will help the patient, and these are the data that is. And you can see it yourself. It's not somebody, a professor telling you are good, not good, etc., right? The data is available. third part of it is the adoption. And I think that's where Mark and the team are doing such a good job. Trying to train people at different levels in a different way. Yeah, so if you take a training program and say, this is the only way you can train, you can never, right? And I think that is what is helping us. So we have a clear understanding, like Mark said, whom to approach in what way and how to create it. I think the next one is affordability. So in some ways, the access has been limited because of that, okay? And when we are going into markets, we are into 20 markets, including emerging markets, not differentiated, I think we know the right way to do it, yeah? So I think they thought about it, and they approached it in that manner. So if we have done this 15,000 surgeries, I think a lot of it is done in markets where robotic may not have even been known sometimes, yeah? And I think the last part of it is they are continuously engaged and aligned with the education system, the governments, the policy makers. So when I look at it, it was an organization almost prepared for it, needed to understand how to commercialize this better, needed to do it in a very focused manner, needed to find a way to, like Luke explained, create the right product portfolio strategy and things like that. So that was the excitement, and that's what I am here for, right? Find a way to continue to develop Versius into new areas, which will provide better, obviously, results, and also to reach more and more patients in more and more markets.
I want to come back to that commercialization strategy, but something you said about the opportunity for robotics to penetrate areas where the awareness is low. Dr. Slack, when we first met, you said that you don't think the industry or the world more broadly has an appreciation for what robotics can be in medtech, beyond what we see today. Can you maybe share some of those thoughts as to the future of where this can go clinically, technologically, Luke as well, but what can robotics be that we haven't seen?
I mean, the first thing is the penetration of the market. So there's a growing awareness that poor medical technology and poor delivery of decent medical systems is an economic impairment to many low and middle income countries. And they actually are aware they need to up the game in terms of standards and so on. So we don't distinguish. If you need a robot for a person having an operation in New York, you also need a robot for a person having an operation in Karachi. And we have followed that strategy. The other one, just to put in, is safety. In the 90s, when minimal access surgery was introduced, it was almost carnage. There were many thousands of people injured and harmed with a poor introduction. So that's why we invested so much in education to make absolutely certain it was safe. But in order to measure that safety, we have a registry of all comers. So when people start using the robot, all their intraoperative and their postoperative details are entered into a registry, which is then delivered to them on an app on their phone, and we can actually confirm. And we have published data in big journals like Annals and British Medical Journal demonstrating that we have safety equal to, if not better than, the published robotic and laparoscopic literature. But of course, we're just starting to now prize open where can we do better. And I've always been reluctant to say robotics is better than minimal access. I just wanted to say it is good as, but easier to attain, and therefore will be better for the community. But we are now starting to see the glimmers of where it is better as well. And in some small, especially our Versius robot, in small cavity surgery, we think we can really do special things in pediatrics and in transoral robotic surgery and in thoracic surgery, where the small cavity that we're operating in and the smaller factory of small ports makes a big advantage. And I'm now getting surgeons approaching me with ideas saying, I think your robot will be good at that. And that's the exciting point about having it in the hands of so many surgeons around the world, is the feedback, and we are very open to feedback, is now helping us see where we should strategize and where we should go in order to really be using the robot where it is best.
And it's such an exciting promise. I think some of the common pushback on robotics from those that are aware and have adopted has always been that there is potentially a cost increase without necessarily a clinical benefit to the patient that's provable empirically. You talked about the ergonomic benefits, but here you're citing areas where this robot is going to enable new approaches, current approaches to be done better for the patients and the clinicians, which really opens up a whole new possibility for...
Yeah, and things like, take something really common like pain. Now, pain, people laugh off. Pain is killing more Americans than the Vietnam War, the entire AIDS epidemic, and motor vehicle crashes.
Wow.
So 7% of patients put on an opiate analgesic post-op will be addicts a year later. 7%. So anything that reduces pain and obviates the need for opiates is really important. And because of the way Luke's designed this, when the robot goes in, and Luke can explain more, it knows exactly where it passes through the skin. It's called a virtual pivot point. So our robot puts no pressure against the skin. And we are noticing a marked, because of the unique architecture of the Versius, we're noticing a reduction in pain, which is fairly significant, and we've even seen it in some of our laboratories, preclinical laboratories, with porcine models. So those are just all stuff that's really coming together, as we see the excitement, and of course that just excites us even more.
And yeah, go ahead, Luke.
From a technical perspective and from a product perspective, at some levels, I'm really proud of the fact that if you look back on the sketches and the CGI we had 10 years ago, we basically got it right. So, Versius looks a lot now like it looked then. I think some things will continue to change and improve. The range of instruments, all the boring stuff, the range of instruments, advanced visualization, all of that sort of regular stuff will continue to get better. What ultimately, though, I aspire to is people not noticing there is a Versius in the OR. And by that I mean, currently it's like, we've got a robotic system, ta-da, or ta-da, depending on which one you've got. Actually, I want people to come into an OR, and will there be arms perhaps attached to the ceilings or on a pedestal to the side? Yes. Will there be a console? Yes. But all of that is essentially transparent. It's just part of the furniture in every OR for doing minimal access surgery. Why would you do it in the extraordinarily difficult manual ways that Mark describes so well? It should just be the ubiquitous tool for enabling everyone to have minimal access surgery. And when it achieves that, it won't be special. That's really where I want to end up. This technology, derivatives of this technology, enabling everyone to have the right kind of surgery. And at that point, it'll just be mundane.
That's amazing. Supratim, it sounds like there's a big vision here to deliver on, and obviously coming into the CEO role, you're keenly aware of the market concentration that exists today in surgical robotics, other players in the space. How are you thinking about the future of commercialization of the company with the new capital that you raised? What role does that play? Talk to us a little bit about where this is going next.
Yeah, I think the first and foremost step is continuing to focus on how to keep providing a better and better Versius in the future. So when we look at the investments, that's what the first thing we have to look at. So Luke talked about the ideas. Mark said what Versius should be able to do. And what would it make us to make this a part of the normal operating room? Anybody builds an operating room, it should not be, I have a robot. It's part of any operating room. I think that vision itself is the part of the thing that we are trying to look at and how to create here. In terms of commercialization, we will continue to focus and look at markets where we think the penetrations are low, the market creation can be done, and so we have 3 levels of approaches to look at. Where there is robotic already done, where there is no robotic done, and when there is a mix of part reach not there. And concentrate in a manner that people appreciate and understand how the Versius fits in the overall approach, and take the path which will reach it to more and more hospitals and patients. So finally, the whole commercial strategy would be what Luke explained, that everybody should appreciate and adopt it, and we put it at a level and we build models which will enable hospitals to adopt it. So we have to be creative in different markets. We have to build business model which is market appropriate. We are not going to standardize and say this is the only way to approach the market. And so that's where the main focus is today. Create a market-appropriate business model which will help us to reach more patients.
But also, and the entire company is really behind this. And actually, I'm in a very privileged position of being a chief medical officer in a company that's as progressive as it is towards patient well-being, patient health. When I speak to Tim or to Luke or to Supratim, I get it. We have been committed to evidence-based medicine. We've done 350 cadaveric studies before we touched a human. But we are also committed to value-based medicine. And I'm afraid the world has to actually start to embrace value-based medicine. We can't just have introduction of fancy tools and tricks unless they are genuinely doing good and at the same time adding value to the society that we are working within, the medical society. And so a lot of what we've done, and every single thing we do, we publish, so that we have this commitment to evidence-based medicine, and most especially value-based medicine, because otherwise we will live in a world, especially in the high-income countries, where we will no longer be able to afford our health systems.
Luke, maybe to kind of start to wrap us up, and then we'll go down and hear some closing thoughts. You talked about some of the software innovation and the digital features that we'll be able to enable, having monopolar, bipolar energy or stapling that's being done outside of a field of vision corrected or stopped, or at least reminded and questioned. Things like that are interoperative digital solutions on top of this architecture. Maybe set the stage a little bit more for the future of what a next generation Versius system could either look like, function like, some of the features that could be present in that system. Will it involve hardware and software, or purely this architecture with a beefed up software ecosystem built on this registry?
The hardware will always be important. I mean, the statement you made earlier about software becoming more and more important, absolutely true. You fundamentally can't do many of these things unless you have first-class hardware. So you have to have the robot. The things that I imagine will be different, though, is ever so slightly the kind of sort of man-machine interface and control during the procedure will have changed. The surgeon will both be being fed more information in terms of preoperative imaging, but also the steps of the procedure. Standardization of surgery. First we do this, first we do this, then we do this, then we do this, then we do this. And the system will track as you move through those steps. So information coming in. And secondly, that guidance as well. Okay, we're doing this step. Actually, you shouldn't be over there. You should be over here. Do you really need to be over there? Or what about this instrument you've left over there? So I think you'll find it'll be much like the experience of driving a modern car compared to the experience of driving a car 50 years ago. You get into a car now, first thing you do is you say, where are you going? And you put it into the sat-nav. The second thing you do is you have to brake hard. The ABS cuts in and stops you skidding. Neither of those things happened 50 years ago. If you imagine in surgery, I think the equivalent of those things will happen with surgical robots. And most of the time, actually, it won't make a lot of difference because most surgery is pretty good. But when it does make a difference, you'll be very glad it was there.
Yeah. And I appreciate that call out, too, to not just the interoperative digital solutions, but the preoperative imaging that you mentioned.
Absolutely.
The postoperative patient outcome monitoring and how that feeds back into surgery and what we can learn. Mark, maybe a couple comments on that as we close up here as to where you're thinking about not just interoperative digital solutions, but pre, post, and perioperative digital solutions, whether through partnerships or your own development to help continue to build this ecosystem.
Yeah, no, well, I mean, on a lighthearted note, Luke is very passionate about those changes in modern cars because the car he drives is about 50 years old and probably shouldn't be allowed on the road anymore. But anyway, that's an aside. Yes, I think, surgery has to be considered in the whole. It's your preoperative phase, it's your intraoperative phase, and your postoperative phase. And good surgery encompasses all three of them, those phases. And so I can see where we start to add analytics in pre-op preparation that help us during the operation. And then like we have the registry, that we way more sophisticated, looking at the use of, and it's a slightly dirty word, wearables, with what they can do to help you with your monitoring and so on. And so I do see a much more structured environment. And also, these software excitement where, as Luke said, where it would say, right, you've got a patient who's this old, and you're going to do this, and the survival rate for a person with that combination is X, do you really want to do that? So I do think we're moving into a very exciting phase in medicine generally, and we're very excited to be part of a small part of it, producing a tool that really, really makes a big difference.
Fantastic. And Supratim, we'll pass it to you to end us with some closing thoughts on the market, CMR Surgical, the story, and where you're going.
I think, like we started with, it will be a very attractive market in the long term, robotic, and the growth rates will continue to be high. I think for CMR itself, 15,000 procedures done, launched in 2019, 2.5 years in COVID. So actually it's 2.5 years. And we are not present in the world's 3 biggest markets yet because of regulatory, US, Japan, and China. So you have to look at this 15,000 in that context.
Just to start.
So the opportunity for CMR is just phenomenal, right? Once we enter those markets, you can imagine what could be the levels of which we can gain in this business here. So I think as training becomes easier, doctors understand easier that this is easier to adopt, and you train all upcoming younger surgeons, which we plan to do. CMR will stand out as a very unique robotic system. The way Luke explained, there are very creative surgeons doing different things, which we can talk of later, including somebody in Delhi trying to assemble his 5 ORs. So he moves with the system from one OR to another. So entire patient preparation time is almost all ready. So if you look at that, it is stunning what you can do with CMR, right? So you are doing 10 procedures a day, one surgeon. So that's the advantage that we want to build on, like I said. Yeah. So once people are aware of this, adoption will be very different. So I think the future is bright both for robotic-assisted surgery and for CMR.
Fantastic. Well, Luke, Dr. Slack, Supratim, thank you very much for joining us here at LSI Europe 23 today and for this conversation. And thank you all for tuning in and listening. Welcome to day 2. We're looking forward to seeing you all.
Thanks.